This is Module 10. We're going to go through some of the basic vocabulary related to causation and correlation. So first, defining association. You'll hear me use the word association and also use the word correlation. Those are synonyms, so they really mean the same thing. You could use the word association or you could use the word correlation. Two variables are associated, or two variables are correlated if the value of one variable gives you information about the value of the other variable. Remember that association does not mean there is a causal relationship. Association is not causation. So for example, the ice cream consumption rate seems to be associated with the murder rate. However, one is not causing the other. Explanatory variable is the independent variable, the input variable. It is the variable that we put along the horizontal axis. It's the variable that we think is explaining the change in the response variable. The response variable is the dependent variable. It's the output variable. It would be the variable along the vertical axis. It's the variable we think is being impacted or changed by the explanatory variable. Note that sometimes it's not really clear which one is which. Sometimes you can't really tell which one is explanatory and which one is response, and sometimes it's fairly obvious. So, for example, it might be the case that we have a variable of whether or not a person has a pet, and another variable of whether or not that person is a person who regularly exercises. So you might say that having a pet is the explanatory variable, and that in response, the person might become a person who is a person who exercises because you have to take that pet for a walk. So in response, they become a person who regularly exercises. Alternatively, it might be the other way around that you think about it. You might say, all right, I'm a person who regularly jogs and I get a little lonely, so I decide to get a pet. So in response, I get a dog to go jogging with me. So I could see it really either way. So sometimes it's not obvious which one is which. Confounding variable is an important thing to understand as we discuss the idea of causation versus correlation. A confounding variable is an outside influence that changes the effect of a dependent and independent variable. It's a variable that's related to both the explanatory and the response variable in such a way that its effects on the response variable can't be separated from the effects on the explanatory variable. A confounding variable can ruin an experiment and produce useless results. When we're conducting an experiment to understand the relationship between two variables, we need to try our best to remove all confounding variables from the experiment so that we are really only studying the relationship between the explanatory and the response variable. So, for example, the tobacco companies were claiming that there was this confounding variable, this hidden gene that was really causing the correlation between lung cancer and smoking. They were claiming that there was a gene that caused people to have an increased rate of lung cancer, and that it was the gene that was causing the increased rate of smoking, and therefore it made sense to see a correlation between lung cancer and smoking because people would have the gene. It turns out that gene didn't exist. We'll talk about how to figure that out in the next video. Another example, confounding variable in the ice cream murder rate example is the temperature. It turns out the increased temperature would cause the increase in ice cream consumption, and the increased temperature would cause the increase in the murder rate. But therefore, you would definitely see a correlation, an association in the ice cream rate and the murder rate. But it's not that the ice cream rate is causing the murder rate changes. It's the temperature that was doing it. It was the confounding variable of temperature that was causing that correlation. So, in order to differentiate between these two, in order to figure out, do we have some hidden confounding variable that's causing the correlation, or is it that the explanatory variable changes are actually causing the changes in the response variable? In order to figure that out, we have to make sure that there is no other confounding variable in existence. We have to remove the possibility of a confounding variable causing correlation. How do we do that? We're going to do that by creating an experiment using random assignment. And see the next video to see what we mean by that.